Hi everyone, welcome to another PSC session. Today we are going to discuss a problem named angry people. Let's move to the description part. It is saying you have a circular dining table and an angry people. You need to place them on the table so that and each person has an anchor value, okay? And you can place them in any order on the circular table. Once you place them, then you need to calculate the danger value of the arrangement. And what is that? The danger value of the arrangement is the maximum difference of anchor values of all the adjacent seated persons. Means all the neighbors, okay? So you need to keep this danger value as low as possible. Okay, so let's write the givens first. What is the givens? We are given with n people and a circular dining table. Each person have an anchor value. We need to place these n people on the table and calculate the danger value of the arrangement. And that is, let's check the sample input. N is 4 here, okay? And the danger value of 4 people, sorry, anchor value of 4 people are given as 5, 10, 6, and 8, okay? So let's move with this. So if we have to put this on the circular arrangement as it is, I mean the order in which they are given, let's first check this, okay? So this will look like this. This is my circular table and this is person 1 with 5 anchor value, 10 anchor value, 6 anchor value, and 8 anchor value, okay? Now, what is the danger value of this arrangement? Danger value will become like this. You have to find the maximum difference among all these, right? And not just among all these, I mean, it already mentioned that, no? Difference of angle values of all the adjacent seated persons. Okay. So if I'm here, so I will try to find this difference, this difference, this difference, and this difference, right? Because they are seated adjacent to each other. That's why absolute value of 5 to 10, 5 minus 10, 10 minus 6, 6 minus 8, and 8 minus 5. Okay. So what will it become? Maximum of, because 10 minus 5 gave 5, 6 minus 4 gave 4, sorry, 6 minus 10 gave 4, absolute value, okay? And 6 minus 8 gave me 2, and 8 minus 5 gave me 3. So among these, what is maximum? Maximum is 5, okay? We can see that. But at the same time, in the question, it is saying you need to keep this danger value as low as possible, okay? So though this is the danger value of this arrangement, but this is not the minimum. Okay. So we need to find such an arrangement where the danger value is minimum. Okay. Find the minimum. Okay. So for current arrangement, danger value, we have already saw that, and we need to make it a minimum. So let's see from the sample output, what is given there. Okay. In the sample output is 4, and in the head, it is given this arrangement. Okay. So let's draw this arrangement. This is my circular table, and the different arrangement is this 5, 6, 10, and 8. Okay. So in the array, you can just, I mean, it however you like. But first, let's find the danger value of this arrangement. So again, we are finding the absolute difference between 5 and 6, 6 and 10, like this 5, 6, 6, 10, 10, 8, and 8, 5. Okay. So what will it give me? Maximum of 1, 4, 2, and 3. So this is my minimum danger value possible. Okay. It's in the output. So it is smaller than the previous one. Okay. So we saw this is the best arrangement with minimum danger value, but we don't know how we reach here. Okay. It's not given in the sample output. We need to find that. Okay. So with moving to the approach part, but though this input was small, okay, only 4 items are there. So I want to take a bigger input. Okay. Let's take with deal with 6 items. So that's why I have taken a bigger array here. So we will move on with this. So approach number 1. Let me ask you a question first. Tell me an arrangement where there is a minimum difference between adjacent items. Okay, think about it. You'll know. It's a sorted arrangement, right? Let's try it. Here in the sorted arrangement, see here, when we sort this 5, 6, 8, 9, 10, 11. This is my sorted sequence, and we can see that right now that the neighbors of 5 gives a minimum difference than any other items left in the array, right? Similarly with 6, the neighbor is 8, okay? And it gives a minimum difference with 6 compared to any other item in the array, right? Similarly with all these. Okay, so let's try to find out the danger value here. Okay, so what will be this? See, this mod is for the absolute difference. Okay, so that's why I've just made it symbolic. So 5 minus 6, 6 minus 8, 8 minus 9, 9 minus 10, 10 minus 11, and 11 minus 5, because it's a circular arrangement. No? That's why 11 minus 5 also will be here. So maximum of this, and 6. You see, everything was going well. The difference was minimum, minimum, minimum. Okay, the minimum possible, we can say that. But at last, in the end, this is my sudden change. Why? Because the drawback with this is arrangement is the first item is the smallest and the last item is the largest in the sorted arrangement. And this is a circular arrangement, means we are on a circular table. So first item is neighbor of last item also. That's why the difference became the biggest. So that's the flaw with this arrangement. Okay, but this can be corrected. Okay, this can be corrected. We'll see in our next episode. We will continue with the sorted approach, but with a little change. Okay, and what is that change going to be? Let's see. In the sorted arrangement, though we are on a circular, we are going to put all these people in a circular arrangement. Okay, so on a circular arrangement, we already saw that if 5 is here, 6 is here, 8 is here. Okay, I mean, any person, 9, 10, and 11. Okay. For 5, if we point to 5 now, then 5 have two neighbors, not just one. One is 6 and one is 11. Okay. So I need to find two neighbors with minimum difference, right? Two neighbors with minimum difference. So in the sorted arrangement, I have already found my one. What my first neighbor gives me minimum difference, right? So I need to find one more person who gives me second minimum difference. Okay. So in the sorted arrangement too, already, I mean, my second neighbor gives me next minimum difference. Like here, 5 minus 6 will be the first minimum. But at the same time, my second minimum will be given by this, right? 5 minus 8. Any rest of the items can't give me that difference, correct? So because each item is going to have two neighbors, so we need to find I mean, the approach should be like this: find the first neighbor and the second neighbor, taking the first neighbor and second neighbor from the sorted arrangement, and then put them on the circular table. Okay, like if I put 5 here, if I put 6 here, the first neighbor, then second neighbor, I am going to put like this only. Okay, that way. Okay, so that's exactly the arrangement that we are going to follow. So let's first do this. Okay, let me put it this way. And let me start with 5 in the sorted arrangement. Okay, I put 5 here. If I take just, then what neighbor I can put? The first neighbor I will put is 6, correct? Second neighbor I can put is 8. Now move to 6. First neighbor I already know on the, because when I put these people on the table, now we can see that 6 already have a neighbor which is 5. So what is the next neighbor? 8 is the next neighbor which will give minimum difference, but 8 is already taken or already kept on the table. So 8 can't be taken, okay, for 6. So next neighbor we can take, right? Because the next difference will be minimum with 9 only. So we'll put 9 adjacent to 6, okay? Now move to 8. Similarly, 8 also have one neighbor already. So we need to find the next neighbor. Next neighbor is going to be 9, but we can't take it because it is already taken or already placed on the table. So next we can take is 10, correct? So let's take the 10. Move to 9. 9, one neighbor is already here. We need to take another neighbor. Another neighbor can be 10, but 10 is already on the table, so we can't take it. So we'll move to next neighbor, which is 11. So we'll put 11 here. Similarly with 10. 10, we have both the neighbors, so we won't do anything. 11, we have both the neighbors, so we won't do anything. Okay. Now for this arrangement, we can write, let's write in the same order. Okay, 5, 6, 8 we written. Then for 6 we wrote 9. Then for 9 we wrote 11. Okay, and for 8 we wrote 10. Okay, yeah. So I think this is my arrangement. Oh, let me show you how I put this in the array also. Okay, otherwise you will be a bit confused. First I have taken 5. Okay, first neighbor I put for 5 was 6. Okay, and next neighbor I put for 5 was, I mean the next minimum difference was with 8 only. Okay, now I move to 6. So I already has one neighbor for 6. I need to find the second neighbor. 8 was the right person, but 8 was already taken. So I moved to next neighbors, which was 9. So I put 9 next to 6. Okay. Then I move to 8, this person. 8 already have one neighbor. I need to put next neighbor. So 9 was the right person, but it is already taken. So I took 10. That's why I put 10 here. Okay. Then after 8, I move to this 9. 9 already had a neighbor. So I need to take the next second neighbor, and 10 was already taken. So I took 11 for 9. Now I move to 10. Okay. 10 already have one neighbor, and next neighbor was 11 but already taken. Okay, so nothing I can just select from this array anymore. Okay, so I will leave it as it is. For 11 also, when I move to 1, it had one neighbor and nothing is left in the array to select from, so I will leave. So because I have just made this array, but this is going to be shown as a circular arrangement, so 10 and 11 will become neighbors automatically. We just saw that from the circular arrangement. Okay, so this is my arrangement where we have put the, I mean, that idea to work that first and second neighbors, okay, are going to give the minimum differences in the sorted arrangement. That's why we have put the items in that way. Now let's find the differences. Okay, so this will look like this. Let's find the differences. So 5 minus 6, 1 will be here. 5 minus 6, 6 minus 9, 3. These are the absolute differences. Okay, so don't worry about the negative values. The 9 minus 11 will give 2. 10 minus 11 will give 1. 10 minus 8 will give 2. And 5 minus 8 will give 3. So what is the maximum among these? 3. See, this is the danger value and which is minimum. Previous was the 6 and this one is 3. So this is my minimum danger value. Okay. Now we have found the pattern. Okay. So pattern was the arrangement. Okay, now let's try to find the pattern. How from the sorted arrangement we move to this arrangement, right? So for that, first let's try to put the respective indexes of the items or anchor values that was in the actual sorted array. Okay, so though the item is 10, anchor value 10, what was its index in sorted array? It was 4, right? This 4. 8, it was 2. 5, it was 0. And 6, it is 1. 9, it was 3. And 11, it was 5. Okay, I'm going to make a point, so just to be patient. So 4, 2, 0, 1, 3, 5. So what pattern we can find from this? The pattern is all the even index items from sorted array are at the left side of the output array. Okay, in reverse orders. Okay, 4, 2, 0. Okay, and all the odd index items are at the right side of the array in the right order, 1, 3, 5. Okay, you can see this pattern. Okay, so now we have found our arrangement, we have found the pattern in our arrangement, how we reach to that pattern from the sorted thing. Okay, the only thing left is code that. Okay, so let's set the pseudocode. Step 1, sort these, sort this array. So sorted array will become like this. Step 2, making the arrangement, right? Step 2 is about making arrangement. What is that arrangement? Let me write it again for you. How we did this. Okay, so solution is my array which is going to store that arrangement. Okay, actual arrangement. So I just to show you the pattern na, that odd even indexes were at the left part and odd indexes were at the right part. Okay, so for the even indexes, let's traverse this sorted array. Okay, so 0 modulus 2 will become 0. Okay, so this unshift function, okay, this just to insert at the beginning. Okay, and this push insert at the end. Okay, keep that in mind. So 0 index modulus 2 will become 0. So it will be pushed at the beginning of the solution array. Okay, so 5 is here like that. Then I'm at index 1. 1 modulus 2 is not equals to 0. So it will be pushed at back. Okay, pushed at the end. So 6 will be here. Then I am at 2 index. 2 modulus 2, 0. So it will be insert at the beginning. 8, right? Now I am at index number 3. Modulus 2 will become not 0. Okay, which is so 3 modulus 2 is not equals to 0. So it will be inserted at the end. Then I am at fourth index. 4 modulus 2 is equals to 0. So it will be inserted at the beginning. Okay, so 10. Now I'm at the index number 5. Modulus 2 is not equals to 0. So it will be inserted at the end. Okay, now I have traversed my whole array. So it will terminate. So I have found the complete arrangement, established this arrangement in my solution array. Okay. Now what should be my step number 3? Step number 3 will be finding the maximum danger value. Okay. So how I am going to do that? This is just a simple code using a for loop on this arrangement, the solution array. Okay. And find the absolute differences here and marking my or updating my max variable. So at the end, it will get the max like this. Okay. You can see how it is going to make. Right. Let me put it this way. 10 minus 8, 2. 8 minus 5, 3. 5 minus 6, 1. 6 minus 9, 3. 9 minus 11, 2. 10 minus 11, 9 minus 7, okay. And then 11, it's a circular arrangement now. So that's why 11 minus 10, 1. So out of this, what is my max? 3, correct? That's why we'll get 3 as the maximum danger value of this arrangement. I hope you all understood it well. Okay. So I will end the session here. Thank you. We'll meet in next session.